go and um, do some marking. So that is why the upload delayed. At this time, I am home. I'll be here to do the uploads. So we are beginning the third chapter, and the third chapter is on the geology, relief, and drainage of West Africa. Geology, relief, and drainage of West Africa. All right, let's understand the terms used here. What is geology? Anybody? Geology. Hmm. Nobody is giving any answer. Ebenezer, I didn't want to talk.
He said scientific study of rocks.
All right, so that is geology. You study rocks. But note that geo means F. I hope you know that. And then logy means study of. Hmm? And by this, if you're studying the F, it means you're studying the rocks because the F is made of rocks, different types of them. And so that is geology, the science study of the earth or rocks and their formation. How about relief? Relief. Two keywords to stand for relief. Relief can be represented by two keywords. What are they?
Highlands and lowlands.
All right. So Ajima, that's correct. And then drainage. Drainage, we have about 4 or 5 types of drainage. What are they? Mention them. Or just one word or two words to stand for drainage. Who is there? Noah.
Sir, it refers to all water bodies.
Exactly. Those two words were the ones I was looking for. Water bodies. So if you hear drainage, we are referring to water bodies. And remember, water bodies come in different types: oceans, seas, lakes, rivers, ponds, streams, even springs are part of drainage. So these are the things we shall be looking at under chapter 3. And the chapter is to do with all this and refer to these as natural features or physical features of West Africa. And so to start with, it says that our subcontinent, our sub-region is divided internally. All right. We use geology, we use relief, we use drainage and others to divide West Africa. That is to say, just like Ghana, we can divide Ghana using maybe vegetation. We can divide Ghana using relief and even drainage. You understand? So the same we are doing for West Africa. All right. Now, our West African sub-region, and anytime you mention geology, and I'm starting with geology now, the study of rocks, the earth, and rock formations. Anytime you mention geology in West Africa or any part of West Africa, one word that you should always pay attention to is Precambrian. Precambrian, Precambrian, Precambrian. All right. It's a period in geologic history. And remember that the earth you see today was not as it is now. In the beginning, it was messy. Even the Bible attests to that, that it was messy. In they say, "Na asase so yɛ sakasaka." And so a whole lot have occurred, giving us the land, the earth as we have today, the terrestrial earth. All right. And so when we mention that something has happened, it means it didn't happen just within a year or two or even a century, millions of years ago. Therefore, in West Africa, mentioning rocks, we talk about rocks known as Precambrian rocks. Precambrian rocks. These are rocks that are very, very old. They are about 541 million years old, and they constitute the oldest type of rocks in West Africa. All right, the oldest type of rock in West Africa, at least 541 mil. No, did I say? Yeah, million years old. All right. Now, one thing with these rocks, and I'm giving you two characteristics of these rocks that we have in West Africa, not just Ghana, but the entire 16 nations of West Africa collectively. These rocks that we refer to as Precambrian rocks have been folded and fractured over hundreds of millions of years. All right. Now, rocks go through some processes. One of them is folding and faulting. In folding and faulting, we have fracture or fractures. So when you say rock has folded, it is just a common word, just like if you're folding something, and it happens like that. But let me also mention that in geography, when you mention rocks, you are not talking about those hard substances that sometimes you can even carry or lift, or the boulders. No, we are referring to any part of the earth that constitutes a stretch. For example, you can have clay at one end. The clay there is a type of rock. You can have silt at one point. Silt is a type of rock. We can even have sand. It is also a type of rock. So here we are not talking about the hard things that you see. Okay. And that is how come we are saying that rocks can fold. Because if you do geography, we are folding and faulting. Just imagine rocks are folding. All right. It must sound absurd. But it does happen because you are not referring to the hard things that we know to be rocks. No, we are referring to some of the things that I mentioned. So they can fold and then they can fracture. And so the Precambrian rocks in West Africa are folded and are fractured over years, so many years ago. Now, another thing about geology of West Africa is that a part, one third of these rocks that we are talking about have been exposed. In other words, um, they used to be buried beneath the surface. Now, due to some denudation activities such as erosion, they are now exposed, meaning they are now on the surface. You can see them. And some of them are even forming elevations. In other words, some of them are forming rock outcrops, huge ones. And some can rise into the sky to a height of 400 meters. All right. So note that these rocks have been exposed. That is the third thing you have to note. The next thing is that uh, there was a time in West Africa when we had undulation. The land was rising and falling. It wasn't as smooth as you see today. Okay. So the fairly level floor that has been provided by eroded surfaces of Precambrian rocks. That means that those undulations have been eroded. All right. They have been eroded. And now we have the rocks standing out, as I mentioned earlier. And because the undulations are no more, it is allowing for some activities of the sea happening. That is to say, the sea or the ocean undertakes two major movements, back and forth movement. We refer to it as swash and backwash, swash and backwash, okay, or advance and retreat. So the ocean advances and then it retreats. That, this is possible because Sorry for the interruption. The monitor in Kekus was trying to, um, yeah, he was trying to know whether I was here or, yes. I'm on my deep cry, but I hope you can hear me. Hello, can you hear me?
Yes, sir, we can hear you.
Uh, He was trying to join, but it was not possible for him. So there were undulations. But after some time, remember in history, we have had what we call pluviosion, where it rained for many years on ending. So there was some kind of erosion. All the undulations were removed. Undulations are rise and fall of the land. Sometimes you see a highland, at that time it's a lowland like that. Okay. Now because of this, it allowed the ocean, the sea, to undertake some activity. As I mentioned, it is known as swash or backwash, or here we refer to it as advance and retreat. Okay, so because erosion occurred, it allowed for the sea to advance and retreat, to come closer to the coast or to the shore, and then later move back, as it happens when it gets closer to the ocean. That's what I'm talking about. Okay, yeah. So that's about it. Now, the this back and forth movement, as I mentioned, resulted in two things. Because the ocean, the sea carries a lot of material, a lot of materials. You know that. Okay. So when it gets closer, when it is swashing, when it is advancing, or when it advances, it deposits new materials. It deposits materials, I mean. And when it is going back, it also carries. So it erodes materials. As it comes onshore, there is deposition. As it goes back into the valley, it carries materials away. So there is what? Erosion. So erosion and deposition occur as the ocean engages in advance and retreat movement. Okay, so in West Africa, there are examples of the ocean having undertaken such activities. So within the Senegalo-Mauritanian basin, all right, if you have your map, and I've told you to get the map of West Africa, I've already also told you to learn how to sketch the map of West Africa. If you have your map, you will see that Mauritania and Senegal are neighbors. All right. Mauritania is a Sahelian country. It sits on top of Senegal, just like Burkina sits on top of Ghana. All right. So between them, the ocean, because those two countries are also coastal countries, between them, the ocean has undertaken this advance and retreat movement. And therefore, and a lot of sediments have been deposited by the ocean. All right. And then we also have Western Mauritania, still Mauritania. That place too, we have the swash and backwash happening. And so there is um, deposition and erosion occurring. Then Senegal and into Guinea. If you have your map, you see that Senegal has Gambia close to it, or Gambia is encircled by Senegal. After Senegal is Guinea-Bissau, then after Guinea-Bissau is Senegal. So if you check, you see that Senegal as a country is sharing boundaries, international boundaries with three countries, three of them. It shares a boundary with Mauritania, it shares a boundary with Mali, it shares a boundary with Guinea and Guinea-Bissau, as well as Gambia. All right, so three countries. Therefore, between Senegal and Guinea, we have this kind of deposition happening. Okay, and so that is it. But let's look at some examples of highlands that we have in West Africa. All right, we call them massifs. massive, AMMASSIFS, massives, and highlands. So we have the air mountains, we have the Tibet Mountains, we have the Andrade Ifugas Mountains, and then we have the Putajalon mountain. All these are formed by the Precambrian rocks or the Precambrian folds. They are fold mountains and they were formed from rocks belonging to the Precambrian branch. All right. Now, in West Africa also, talking about geology still, we have some denudational activities happening, and they are known as volcanic activities. All right. So volcanic activities have been happening within the West African sub-region, and these activities have caused the deposition of additional layers of igneous rocks. All right, because volcanicity has to do with the eruption of magma, the welling up of magma either onto the surface or just beneath the surface. And magma is molten rock. So it tells you that rock can melt at a certain temperature beneath the surface of the earth. All right. And any liquid thing will not stay silent. It will have to flow. It flows, all right, under the surface. And so when it gets to a place where there is a crack or an opening, it forces itself through the opening. It is just like having a kind of tree or plant germinating or maybe around a concrete area. When it germinates, maybe there was small soil there, but as soon as it germinates, the roots will be wandering, will be moving around looking for openings to enter. So when it gets a small opening, it enters, and then as it grows, it expands the opening. The same thing we are talking about here. When magma forms under the surface, it flows and looks for an opening. When it gets that opening, it flows through it because down there, because it is warm and hot, it has pressure. There is pressure building up or having been built up beneath the surface. So it passes through the crack or the opening called vent and gets onto the surface. So this is happening within the West African sub-region. So as recent as 2.5 to 3.6 million years ago, we had this kind of activity where volcanic activity erupted, happened, and deposited igneous materials on the surface of the West African sub-region. So mountains like the Tibet Mountain and then the Air Mountains are all mountains that were formed as a result of this volcanic activity. Okay, so moving on, let's look at, so apart from the volcanic activity, we also have another denudation activity known as weathering. Weathering is occurring also in West Africa. All right. And all these things that I mentioned are part of geology. Weathering is occurring within West Africa, especially within the within the sandstone areas. So intensive weathering of sandstone during dry periods in the late Quaternary, and the Quaternary period was between 0.5 to 1 million years ago. That's what I told you in the beginning, that when you say something has happened in geologic history, you are not only talking about centuries, you are talking about millions of years. And when this weathering happened, volumes of sand, volumes of sand were deposited in Kano in Nigeria, Ouagadougou in Burkina, Bamako in Mali, Dakar in Senegal. All right. So over there, we had weathering depositing sheets of sand. And all these are West African countries. So that is all about the geology of West Africa. Any question? Now, from there, we move on to relief of West Africa. As you noted earlier, relief has to do with highlands, and lowlands. So remember that West Africa has highlands, it also has lowlands. Some of the highlands are plateaus, others are proper highlands with peaks. Some of the lowlands are plains, and even some of the highlands are high plains. You have all these in West Africa. And so we're going to look at places in West Africa that are below 400 meters. In geography or in measurements, if any place is below 400, we refer to that place as a lowland, as a low lying area. You might think it is 400 from where you stand, but 400 above sea level. Wherever you are many, many, many meters above sea level. You understand? Many meters above sea level. So when you say a place is 400 meters, or we're looking at if a place is 400 meters, it is lowland. We are not measuring from where we stand. We are measuring using the sea as the starting point. Okay. So the first lowland in West Africa, or low-lying area in West Africa, we have it around the coast, the coastal areas in West Africa. And indeed, the ocean is the ultimate level. And the lowest part of the land is in the ocean. And so if you want to talk about um, lowlands in West Africa or low-lying areas in West Africa, obviously you are likely to find those low-lying areas um, along the coast. So it is there that we have lowlands. Okay. But apart from the ocean, apart from the coast, we also oh okay. We also have a place like the Chad Basin. Chad is a river, remember, the Chad Basin. And we also have a country called Chad. So the basin of Chad also provides a low lying area. And then the middle of the Niger Basin, there's a river in West Africa, the longest, the biggest river in West Africa, River Niger. Okay. In the middle of its basin, you also have low lying areas. So that is the first point. And the second point under the lowlands of West Africa is that lowlands are narrower. Lowlands in West Africa are narrower in Guinea and Sierra Leone. So if you look at the coastal areas, as I mentioned last week in West Africa, sorry, we have Mauritania, Senegal, Gambia, Guinea-Bissau, Guinea, Sierra Leone, Liberia, Cote d'Ivoire, Ghana, Togo, Benin, and Nigeria. Okay, and here we are making the point that the lowlands in West Africa, parts of it are narrower, parts of it are wider. So if you check from Guinea and Sierra Leone, and if you have your map, you see that Guinea and Sierra Leone are neighboring countries. Okay, over there we have the ocean being so narrow, meaning that the lowlands don't extend far from the ocean, from the beach into the land. It is not that wide. It is not big. The land that the lowlands occupy are not big. That is what we mean by narrower. But in Mauritania, in Senegal, in Gambia, and in Nigeria, it is the opposite. The lowlands are very wide and very huge. All right. Now we are done with the lowlands. Let's go to the highlands, the high plains, interior high plains in West Africa. And here we're looking at a height of between 400 and 1,000 meters. So any place that is 400 and above, all the way up to 1,000, is a highland. Okay. If the top is a plain, that is open area, vast, you refer to it as a high plain. So in the interior of West Africa, we have high plains. Now, the first area that forms part of the high plains of West Africa would be the highlands, which are above 1,000 meters in height. So we're going to look at some highlands in West Africa. I've mentioned some of them already, and here we're going to describe them and see how they look like. All right. And so the first one, which is part of the high plains of West Africa, standing between 400 and 1,000 meters, is the Futajalon Plateau. Futajalon Plateau. Okay. This Futajalon Plateau is very high and it has a grassland. Rolling grassland, meaning the top of it or the sides of it are covered by grass, as we call in our local parlance and in science, standing to about 900 meters. Okay, when you say a place is rolling, it means it is not standing steep. All right, it is not standing steep. It rises gently all the way up to 900 meters. Okay, and the next thing about the Futajalon Plateau is that on the plateau we also have mountains because I told you that plateau is a tabletop highland, a highland with a flat, almost a flat surface. And so it tells you that on that highland, we will have mountains rising, meaning that on the highland, you see other people rising. It's just like having an assemblage of human beings. You see so many of them of the same height, but you see one or two of them being taller than all the others. So parts of the plateau, the Futajalon Plateau, are standing higher than the rest. And that place is known as Mountain Lura, Loura. And that is the highest point on the Futajalon Plateau. That mountain is 1,550 meters high. The next thing about the Futajalon Plateau is that it has sandstone, and sandstone is an igneous rock. Sorry, it's a sedimentary rock. All right, sandstone is a sedimentary rock. Okay, but beneath the sandstone, we have granite. So it has a granitic base. Granite is an igneous rock. Therefore, you can say comfortably that the plateau is made up of two types of rocks, sedimentary and igneous rocks. Examples, sandstone for sedimentary, granite for igneous. Okay. Predictably, the next thing about the plateau is that predictably, erosion has happened on the plateau, just like happens on all mountains. All right. Just imagine you have a heap of sand sitting down somewhere and it continues to rain. Okay. Whatever you go and find after the rainfall is the same thing we are talking about here. That erosion by rain and rivers has created deep jungle canyons. Deep canyons. All right. Canyon is more or less an opened um, valley. Okay. So the rain and the rivers that take, and very soon I'll mention the rivers that take their sources from this plateau have eroded parts of the plateau. All right. And therefore, it has created deep jungle canyons. The next thing is that I'm talking about now the rivers that have their sources or that start from the Putajalon Plateau. We have River Niger, River Gambia, and River Senegal. River Niger, River Gambia, and River Senegal. All right. Note that one of these rivers will appear somewhere else. When you get there, I'll tell you. So this plateau area receives a great deal of rainfall. A great deal. It rains over there a lot. That is the Futajalon Plateau. Okay. There's a map that comes along, and the map is showing the Futajalon Plateau where it is located in West Africa. And so you can be told to locate the Futajalon Plateau. And therefore, you should be able to do it because I'll give you that map. On the other hand, you can also Google because everything now is online and check the location of the Futajalon Plateau. All right. Moving on from there, we're looking now at the Guinea Highlands in the west. The Guinea Highlands in the west. Hmm? The Guinea Highlands in the west. Okay. So here we go. This highland, called the Guinea Highlands, extends from the southern part of the Futajalon Highlands. You just mentioned Futajalon, in the southeastern part of Guinea, through to northern Sierra Leone and Liberia. So listen to the names that have been churned out here. It rises from the southern part of Futajalon Mountains or Highlands in the southeast. And then it goes through Guinea to the northern part of Sierra Leone and Liberia. So if you look at them, you will see that all these countries are neighbors. Guinea is the neighbor of Sierra Leone is the neighbor of Liberia, and Liberia is the neighbor of Guinea. So Guinea alone is sharing a common border with Guinea, Bissau, with Senegal, with Mali, with Cote d'Ivoire, with Liberia, and with Sierra Leone. How many countries? So many of them. And that is Guinea for you. And don't forget, it is also a coastal nation. All right. So that is where the Guinea Highlands begin. That's where they start from, the southeastern part of the Futajalon Plateau. And it extends all the way, covering all these countries that I have mentioned. This island is a densely forested mountainous plateau. Densely forested, meaning the forest there is thick. Most mountains are covered by forests, and in Ghana, we normally create forest reserves around them. All right, so it is thick over here on the Guinea Highland. The forest there is thick. Now, the height over there is between 300 and 500 meters. But on this highland, all right, there is also another highland. As I told you earlier, that we can have parts of the highland rising above others. So on the Guinea Highlands, we have Mount Nimba rising above the surrounding or the other parts. And Mount Nimba is 1,552 meters, 1,752 meters high. Very, very tall indeed. Next thing to note under or about the Mount Guinea Highlands is that it has sediments of granite. It has sediments, it has granite, it has schist, and it has quartzite. Okay, so these are the types of rocks that we find over there on the Guinea Highlands. And the last thing about the Guinea Highlands, we're talking about rivers that begin from that place. We have in the west, River Niger, and we have River Sassandra from in Cote d'Ivoire, which is also taking its source from this mountain. So there are two rivers, River Niger. If you remember, I told you that one of those rivers will appear somewhere, and that is River Niger. Okay, because we said that River Niger takes its source from the Futajalon Plateau. And here we are mentioning that on the Guinea Highlands, River Niger is also starting from that point. What does that tell you? If you read or if you remember what I told you, I said that the Guinea Highlands are a continuation. In other words, they extend from the southern part of the Futajalon mountain or plateau, if you remember. So it means that they are all within the same vicinity. So one will begin and then it will end. As soon as it ends, another one will start. So this river is more or less straddling. It's standing on both sides. Part of it is in the Guinea Highlands, part is in the Futajalon Plateau, and that is River Niger. No wonder it is the largest, the longest river in West Africa. Okay. Now, the next one, highland, is the Jos Plateau. In fact, there are so many of them, so many of these highlands. All right. After the Jos Plateau, I'll leave the rest. So when you get the slides, which will follow just after the lesson, you read the rest. So let's talk about the Jos Plateau. The Jos Plateau. It is one of the highest places in Nigeria. But the other one is the Nambila Plateau. Okay, so it means that in Nigeria, these are the two highlands, the Jos Plateau and the Nambila Plateau. It is an undulating highland. I mean the Jos Plateau. It is an undulating highland, meaning it doesn't have a smooth surface or a surface that is uniform. A part rises, a part will fall, a part will rise, a part will fall. You understand? Now remember that these mountains that we are discussing are way higher than the highest mountain in Ghana, Afajatu, because Afajatu is only 883 meters. Hmm? But the George Plateau, for example, has an average height of 3,500 meters. You understand? Above sea level. Okay. So on the George Plateau also, we have older granites, granite, and then younger granites. So the two, older and younger, all of them on this plateau. And they have this plateau has a sizable amount of tin, which can be mined for economic purposes. Then this plateau also is made up of volcanoes, meaning there has been volcanic activity over there. So it has a number of volcanoes. A volcano is a place where volcanic activity occurs. I mean, the very area from where the magma erupts is what we call the volcano. Okay. And so rivers like Kaduna, River Hadija, and River Yobe are beginning their journeys from the Jos Plateau. Any question? Now there's a map, so you can Google um, the highlands of West Africa. You get the map, and it will show you clearly where each of them is located. We are done with that one. I mean, there are others. Let me mention them in passing. We have the Air Plateau. We have Andrades Ifugas Plateau. We have the Bandiagara Escarpment. All these are other highlands that I didn't mention. Now, let's look at, we are moving on from there to talk about drainage. So we are done with geology, we are done with relief, we are moving on to talk about drainage. Any questions so far? Uh-huh. Thank you. Silence means consent. Okay, the thumbs up, I've seen it. Elijah, good. Let's move on. So how many do I have here? How many of you? Hey, only 10 of you. Oh, and that was what I was talking about in the beginning. I should think you are more than 10, even though you are different centers. You are. So how do I have 10 people only? And that is why you produce bad results in examination. Hmm? In other words, we expect you to perform highly because you are already teachers. You're already degree holders. Hmm? You're already graduates. You only need some certification in your electives and then you are good to go. But here we are, some of you. Well, let me go on. So
Right, I
we are
think we
now,
are just about 12.
you are 12, eh?
Yes, we are not many. We are just about 12. Yeah.
All of you put together.
Yes, sir.
And even still,
We are 17.
17. So I have 10 here. Oh. Because 6 plus 4, 10. Or 11,
17.
yeah. Mm, I have 11 of you here now. So 6 are missing. I hear. That's it. Why? Hmm. Okay, relief of West Africa. Relief. As you mentioned, relief talks about what? Water bodies. That's a relief. Drainage. Drainage of West Africa. And if you remember, I have mentioned some of the water bodies before. Oceans, seas, lagoons, lakes, rivers, mhm, streams, springs, even ponds. You understand? Hmm. Even ponds or form part of whatever this drainage of West Africa. There are key points that you have to note about drainage of West Africa, and this has most of the times been a part of the exam. So listen, number one, there are four of them. Rapid runoff on crystalline rocks, especially on the south or southwestern Precambrian shelf, where rainfall is heavy. Okay, what does this mean? Remember Precambrian, all right. And I've also mentioned south or southwestern part of West Africa, south or southwestern part. Over these areas, we experience heavy rainfall, heavy rainfall. And because of that, there is what we call rapid runoff. And runoff, yes, anybody, what is runoff? Mm-hmm. No consult to AI. You want to consult AI.
Say, runoff refers to they are running waters.
Mm-hmm. No, what type of water? Yes. Mm-hmm.
For instance, when it rains,
Mm-hmm.
then those waters that flows, whether from the mountains or any of those waters that accumulate and move together,
So
they are all part of the running waters.
exactly. So running water, runoff is the movement of rainwater on the surface. That is the definition. The movement of rainwater on the surface of the earth. So you are right. Yes. All right. So because there is heavy rainfall within this area, all right, the southwestern or the southern part of the shelf, the Precambrian shelf. I mean, okay. So let's describe it as the southwestern part of West Africa. Okay. There it rains a lot. And because of that, there is rapid runoff. Water moving on the surface is very swift. It runs faster because the rain is heavy. That is the first one. The second one, behind the southwestern and Guinea coast, rivers are cutting deep to new base levels. You know Guinea coast, eh? The Guinea coast, you are referring to all the coastal areas in West Africa. All right. So behind, that is if you walk a bit deep into the countries, from the coast into the countries themselves. Okay, what do we have? The rivers over there are cutting deep into new base levels. Every river has a valley. And so if a river is cutting deep, it means that it is expanding its valley. All right. It is expanding its valley. And this is causing a lot of what we call uplift and inward tilting. That means that the rivers, as they cut to new bases, all right, or new base levels, they are creating a kind of terrace. Okay, so the land sitting over the valley or the land close to the valley will now become very steep, and that is what we refer to as uplift. Okay, then the third one says that there is greater maturity and indeterminate courses of the rivers of the sandy central lowland zone compared with the immaturity and vigor of the Guinea coast rivers. So there are two rivers here. One is described as mature. The other one is described as immature. Uh, Within the West African sub-region, along the Guinea coast, okay, of the Guinea coast, along the Guinea coast, the rivers there are, have what we call indeterminate courses. Uh, um, if a river is mature, if a river is mature, that is to say every river has three stages. Mhm. The youthful stage, the mature stage, and the old stage. So when you say a river is mature, it means it has run a certain course. It has gotten to a certain point where the land is not as steep as it began. And over there, the speed of the river is not too swift. Okay. And if a river doesn't have swift speed or the speed is not too great, that river will not be able to create a channel or a valley for itself. And so it will be forced to spread out and disappear. Therefore, some rivers do not join the ocean or other rivers, but they disappear in the sands. And so if you say there's a greater maturity and indeterminate courses of the rivers of the central lowland zone, that means that, remember we said, because of weathering, sand was deposited in some parts of West Africa. Okay, so if a river is mature and that it cannot create its own course, it cannot create its own path, then it means that the river, number one, is not flowing on a steep slope. Number two, the river is close to a desert or a sandy area. And so the sand in West Africa prevents the rivers from flowing. And so the rivers get indeterminate course. What do you mean by indeterminate course is that the river is unable to create its own channel, its own valley. All right, that's what happens. Now, the Guinea Coast rivers. Okay, so remember that the first ones that are indeterminate are rivers that are interior a bit. They are interior because they are into the sands of West Africa. But if you get closer to the coast, it is the opposite. The rivers there are immature, meaning they are running on a steep slope. All right, and so they have a lot of vigor. That is the third point. The fourth one says that greater seasonal variation in river flow. This one is very common. When you are to view the characteristics of rivers in Ghana or West Africa, this point is one of them that you can raise. Okay, to say that there is greater variation in river flows, meaning the rivers do not flow at the same speed. They do not flow on the same surface. Some flow swiftly, others flow gently. So seasonal rains always cause an extension or extensive flooding because they are operating almost on flatland. So seasonal rains cause extensive flooding. And much water is lost by intensive evaporation and percolation in the dry season. Okay, so these are characteristics of rivers in West Africa. All right, moving on. We are now going to pick the rivers one after the other. I mean, the important, the notable ones, notable rivers in West Africa, and then we are to describe them. So give me 1 minute. Less than that, even 30 seconds. Back to continue. So we are now on rivers. Some of the rivers in West Africa. We're going to describe them. All right. You're going to give their characteristics. If you are to describe, it means you are going to give the characteristics of something. Hmm. So here we go. We start off with River Niger. River Niger. Mhm. So you have to Google the drainage map of West Africa, so you can determine, or um, you can know the location of all the rivers you're going to talk about. There are many. I'll not talk about all of them. River Niger. First, we are looking at where it passes. It passes through almost every climatic region in West Africa. Very, very vast, very, very huge. Okay. meaning it is extensive. It goes through a number of countries and it runs through the following countries: Mali. I mean, the southern part of Mali. It goes through Niger. Don't forget, Mali and Niger are neighbors. And then it also runs on the border of Nigeria. So if you have your map, you will find that Nigeria shares a common boundary with Niger. Niger has a boundary with Benin. Niger has a boundary with Burkina. And Niger has a boundary with Mali. So between Mali, Niger, and Nigeria, we can have River Niger. If you study it carefully, you see that there is a country which is known as Niger, but the river is Niger. The same spelling. So you are inclined to say or to believe that Nigeria got its name from this river, and the country called Niger also got its name from this river. So that is the location. Let's look at the length of this river. It is 4,200 kilometers long. That is the longest river in West Africa and the third longest river in Africa. So in Africa, the longest river is River Nile, and the next one is Congo. River Niger will come third. Now let's look at where it starts from. As you mentioned earlier, River Niger is starting from the Guinea Highlands in the southeastern part of Guinea. Guinea Highlands in the southeastern part of Guinea. Next thing is that this river called River Niger has a tributary, a major tributary. There are so many other ones, but the main one is River Benue. That is the main tributary. Okay. Now, when you are told to describe a river, you are going to mention some of these things. The tributary, the area it covers, the drainage features, whether there's a delta, whether there's a rock outcrop. Okay, that's how you describe rivers. Then next thing is that it also has a delta, what you call inland delta, River Niger. So question is, what is a delta? What is a delta? Anybody? What is a delta?
Sir,
Yeah.
when it comes to a delta, the river divide itself into so many tributaries at a point, then they merge again, create a living land within them.
All right. You have gotten very far with it. On a scale of 10, I'll give you about 7 over 10. Yes. You see, rivers, and let me tell you where deltas occur. They occur most of the time when a smaller river is joining a bigger one. All right. That is where deltas always occur. Or when a river is, disappearing into the sands or into the desert, it can also form a delta. So Elijah is right to about 70-80%. Okay. Now, this is how it forms. So I can tell you, physical job to describe how a delta is formed. When a river, as Elijah mentioned, when a river is entering another one, first, that river must have traveled long distances to the extent that it is now on almost a flat surface, flowing on a flat surface. And so the velocity of the river has reduced considerably. That is one. Number two, because it may be entering into a bigger river, that bigger river might have pushed a lot of sand, all right, onto the land. It might have pushed, just like what you see when you go to the beach. The ocean has pushed a lot of sand or silt to the beach. And what is the beach? The beach is the sand that we walk on, that sand. So the same thing happens to rivers, big ones. They also push sand, especially when they are their advanced stage or old age. where the gradient or the slope is very, very, very low. They push a lot of sand to form almost like something like a levee. That's what they do. So when a river is entering such a river, a smaller river is entering such a big river, that small river is also going to run on almost a flat surface or on a beach or on a stretch of sand. Now, when that happens, because that small river doesn't have the energy to create its own path, to create its own road, it is forced to split, to divide itself. So some will go to the left, some will go to the right, some will pass through the middle, some will pass through here, but they all follow the same direction. If it is forward, like as the river was moving, so some will go this way, like that, as if you are doing a spiral. Okay. So after some time, all of those ones come, they will all come together and then it will form a nice shape. So when you get the slice, you will see a map showing the delta, or you can Google and check the delta. So that's how deltas are formed. And we are seeing that this river called Niger has an inland delta. All right, it has inland delta. It has marshes, meaning it has marshy areas. And then it also has a lake. Mhm. It also has what? A lake or lakes, not just a lake, lakes. It says you have big the river is. And the last thing about this river is that we use the river for fishing and agricultural purposes. Okay, people fish in it, and we also use it for irrigation. So that is River Niger. All right, let's move on to talk about the next river. And the next river is known as River Senegal. There's a table, yeah, there's a diagram, a table showing all the rivers or the most important rivers in West Africa and their drainage basins. In other words, the area they occupy. Now, listen, there's a difference between the length of a river and the drainage basin of a river. The length of a river only measures how long the river is from the beginning to the end. But when you talk about the drainage basin or the drainage area of a river, we are referring to all the areas the river extends to. And this, we are talking about all the areas occupied by the tributaries of the river, because every major river has tributaries. Okay, so as you mentioned, River Benue, for example, also has a number of tributaries. So all those tributaries that join River Benue, or River Benue to join River Niger. So the areas covered by those tributaries all form part of the drainage basin of River Niger. Correct. So we have River Niger, River Senegal in that order in terms of their length, all right, and even their drainage basins. In that order, River Niger, River Senegal, River Volta, River Bandama, River Kumwe, River Gambia. We have Sansandra in Cote d'Ivoire. Hey, we have Pra. So Ghana, we have two of them there. Volta is there, Pra is also there. We have River Mono, and then the third one from Ghana, River Tano, and the last one, River St. Paul. These are major rivers in West Africa, but it is gratifying to know that three of them are in Ghana. Three of those rivers are in Ghana. It tells you how resourceful Ghanaians are. We are now on River Senegal. River Senegal. First, let's talk about where it passes. It covers a riparian Guinea. Hmm? A riparian Guinea. Okay, simply, it covers part of Guinea. All right. Um, so it covers part of Guinea, and here we're referring to a part of Guinea that is closer to the river Niger. And then it also passes through Senegal. It goes through Mali. It goes through Mauritania. And it flows for about 1,800 kilometers. Very, very long. Second longest river. 1,800 kilometers. River Senegal. Okay. Now, where does it start from? It starts from a place known as Bafin and Bakoy. Mhm. Bafin and Bakoy. Both of them are within the Futajalon area. Mhm. Yes, within the Futajalon area. That is where this river takes its source from. And then on the massif in Guinea, massif is merely a highland. Then it enters the ocean, the Atlantic Ocean, through a delta. Okay, meaning this one also has a delta. The River Senegal also has a delta. Now, on this River Senegal, people are doing a lot of agro-food business. And they are using this river also for the generation of hydroelectric power. The delta that this river forms is an internationally protected wetland. All right. So it tells you how important. When you say something is protected, it means the UN has acquired it. The UN is disallowing everybody from getting there. And so you cannot go and fool. It is protected. Okay. It is protected. Now, how is it being used? The delta is an international protected wetland. Yes. The 110 million US dollar Senegal River Basin Multi-Purpose Water Resource Development Project. Hey, mouthful. Mouthful. That is the name of one single project too. Hmm? Senegal River Basin Multi-Purpose Water Resources Development Project. This is a massive project that is conducted or made because of this river. And so the countries like Guinea, Mali, Mauritania, and Senegal are tapping into this project, and they are using it for fishing, for irrigation, and for various health activities. Therefore, this river is a very, very important river for those countries. And then it also has delta, as I mentioned earlier. It also has delta, as I mentioned earlier. And so it is also used for fishing and agriculture. Remember, in fact, if you're a big river, definitely they will use you for agriculture. Then let's discuss our voter. I think voter card here. Voter there. Because our voter should be the next river to be discussed. Should I go ahead?
We'll read that one.
All right. So it's a river that we fairly know about. In fact, we know about it very well. So I don't think I have to bother my head. So the other rivers are River Bandama, River Sassandra, River Kumwe, River Mono, River Gambia. All right. All these rivers, I will leave them for you to read because we have discussed and now you know the trajectory. That is the end of chapter 3. Any Kusa. Uh-huh. I'm clear. If there's no question, I'm starting chapter 4. Did I?
Yes, sir.
Hello, please, sir.
Please, you can go.
Yeah.
Hello, sir.
I'm here, please.
Yeah, the River Senegal, where does it enters the sea? Which?
River Senegal. In fact, the book was silent on where it entered the sea. And so I also
Okay.
didn't bother to, I had to look for it. But still, we can Google and find.
Yes, sir.
Okay. So we are starting the fourth presentation or the fourth chapter. Eh? The fourth chapter. Chapter 4. Ready? Yamko.
Yes, sir.
Okay. So chapter 4 is on weather and climate of West Africa. Weather and climate. So I will ask you what is weather and what is climate? Uh-huh. Anybody? Mm-hmm. Weather and climate, yes.
Say,
Mm-hmm.
although they both relate, the
Mm-hmm.
weather is a day-to-day changes in the atmosphere of an
Mm-hmm.
area.
Mm-hmm.
Then that of climate is determined by a long-term
Mm-hmm.
experience of that the or the behavior of the um
Mm-hmm. So you have gotten one of them right. Weather is correct. You are struggling with climate.
Coming.
Yes. Uh-huh. Coming.
The average, as the weather, as he said, is the daily atmospheric condition of a place,
Mm-hmm.
and
Mm-hmm.
the said they were to its weather and climate,
Climate.
and
Yeah.
average weather condition of a place, minimum of about 35 years. So the
All right.
weather of daily and it changes daily, but for the climate takes minimum of 35 years for it to change. So a day we can the weather can change about 2-3 times a day, but for climate
Mm-hmm.
takes about 5 years.
Concise, 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 concise. Except to add that it is not only day by day. The weather can change even second by second. It can change minute by minute. It can change hour by hour. Remember also that weather is measured within a day, but climate is measured over, as she mentioned, 35 years or 30 years. But let's understand something. Oh. The definitions are good, so now you understand those two words. But how do we? Because you said climate is the average weather. How do we determine climate? Hmm. Yeah, thank you.
eh, hello, say,
Uh-huh. Elijah. Hey,
me
Elijah again.
Elijah is in again. So
Okay.
meaning that of climate is determined through observation for a longer period of
Mm-hmm.
a particular area concerning how the weather behaves.
Mm-hmm.
Then at the end, they will come to a conclusion that this pattern or system of weather is experienced at this particular place. So that's how it is
Mm-hmm.
determined.
All right. On a scale of 10, I'll give you some 4. Yes, any more? Anybody? Mm. All right. If nobody is coming, I'm coming in. Okay. Now, to explain this and add the 6 to it so that it becomes 10 over 10. Let's start by identifying the elements of weather first. What are the elements of weather? Mhm. Elements of weather, you don't know what they are? Oh,
So we have sunshine, we have
sunshine, yes.
we have wind, we
We have
have
wind.
the moisture or humidity,
Hmm.
Then yeah, I think I'll pause there.
You need a lawyer. Somebody come to his rescue. Who is coming? We have rainfall, we have temperature. Uh, these are common ones. We have sunshine, we have humidity, we have clouds, we have winds. You understand? Elsewhere, they even talk about evaporation. So these are elements of weather. Elements. Remember them. The usual rainfall that you know, temperature, humidity, and so on. Okay, so those are the elements of weather. All right. Now, these elements of weather are also known as elements of climate because climate and weather move together. We obtain climate from weather. So before you are able to determine weather, you have to determine climate or you have to study that. Sorry, before you determine climate, you have to study the weather. So climate is obtained from weather. Now, how do we obtain climate from weather? Note that all the elements that we have mentioned, 7 or so of them, are all measured at the weather station. They do. You do measure them. And so if you go to any good weather station, you will see the thermometers there measuring the temperature. Okay, now tell me the instruments used to measure each of the elements. Physical jog. I've mentioned the first one. Tell me the rest.
That of wind is wind vane.
Which part of wind? Wind is measured in 2 ways.
Direction of wind, wind vane.
Okay. Uh-huh.
Then hygrometer, humidity.
Uh-huh.
Then thermometer for temperature.
Okay.
Then
Then rain
sunshine.
gauge.
Okay, I pause.
Uh-huh. Okay,
Rain
somebody
gauge
continue.
for measuring rainfall.
Okay. Mm-hmm. Sunshine. Sunshine.
Is it
Sunshine recorder.
or the dial?
Sunshine dial or sunshine recorder. What about clouds?
Octal.
Cloud cover. Are they
Octal.
clouds?
Octal
How do you spell octa? Because uh-huh.
is OCTAL.
OCTOL. Well, maybe I don't know about this, but clouds are measured with ceilometer. CEILOMETERA. Ceilometer.
Say,
Maybe I'll find out.
Hello, please. I can't hear anything. Is it coming from my end?
he said he's coming.
Ah, okay, okay.
Yeah, sorry for the interruption. I'm back. Hmm? I'm back. So you were trying to look for the instruments. My senior man B was calling me to. Right. So those are the instruments. Now, at the weather station, we use these instruments to measure each of the elements. Therefore, it means that each of the elements can be quantified. It means also that each of the elements can be assigned numbers. I hope you understand that. So if it is rainfall, we can have rainfall figures for a day for 24 hours. If it is temperature, we can have the figures for 24 hours. If it is hygrometer, humidity, we can do so. Okay. Now, having gotten these, those figures will form the weather of that particular place. So if you got, let's say, 35 millimeters of rainfall, that is the rainfall or the weather as far as rainfall is concerned over that area. Therefore, we can have figures for days and then the figures for weeks. All right, so let's take rainfall and try to make meaning out of it by way of oh. Sorry, seniors. Anyhow, now. All right, so I was trying to let us do a demonstration of how we get weather, climate from weather. Remember, I told you we obtain climate from weather. So how does that happen? That is why the definition of climate is the average weather condition of a place. All right. So we are going to average all the weather elements, the elements of weather. If you pick rainfall, we are going to average it, temperature, all of them. So we are using rainfall. So let's say in 24 hours, the rainfall figure was, I'll give you any figure, in millimeters. Anybody? Yeah, any figure in millimeters.
24.
So 24 millimeters within 24 hours, correct. That is for day one. Now let's try day two. Day
There
two.
was no rain at all.
For 3 more day. Okay, day three. Day three,
20.
20 millimeters. Day four,
It shoots up to 50.
50. Hey, in shoot of okay.
Mm.
Then day five.
No rain.
Hey, ebio. Okay. Then day six.
There says to no rain.
Okay, yo. That's it. Then the last day, day seven.
It drops down to 30.
30 millimeters. Okay. So we have rainfall figures for 7 days. That is for the week. Now we can sum these figures and have a total. 24 plus 20 will give you 44.
Yes,
44
sir.
plus 50 will give you 94.
94.
Uh-huh. 94 plus 30 will give you 124.
Yes.
Okay, so we have 124. That is the weekly total. Now, this weekly total can be averaged. To average it means you are dividing by 7 because the week is made up of 7 days.
Okay.
You understand? So 124 divided by 7. Anybody with calculator?
Oh, what quarter?
Calculator. 124 divided by 7. I want us to be practical with this. So that next time when you hear climate is the average weather condition of a place, then you know how we came by that word average. So 124, let me use my own calculator. 124 divided by 7. Mm-hmm. That will give you 17.7. 17.7. Okay, millimeters. So that is the weekly average, correct? So this is for week one. 17.7 is for week one. All right. We will not go through week two. Okay. So you use any figure at all in that same line. So week one is 17.7. What do you think you should use for week two? Week two. Anybody to call any figure? Mm-hmm. Oh. Oh yeah. Montemencana.
Say it on.
24.
So call out any figure. Let's go.
24.
Okay, so 24 millimeters for week two. Week three, what figure are you using?
27.
27 for week three. Week four, what figure are you using?
20.
Okay, so now we have averages for the 4 weeks in a month. Averages 17.7, 24, 27, 20. Now we can also strike the monthly average from here. I hope you are following. So we have 17.7, 24 point 24.0, 27.0, 20.0. We can put all these together. Let me do it here. Or if you have calculator and you can be faster than me, let's go 17.7 plus the machine plus 24 plus plus 27 plus 20, correct? And that will sum up to 88.7. The month is made up of 4 weeks. So we divide 88.7 by 4 to give us the monthly average of 22.175. 22.175. All right. That is the monthly average. So let's say this is January. 22.175 is January 1. We can get figures for all the other 11 months using the same method. Now, after we have gotten those figures for all the 12 months, we sum them up in you. We sum them up, all right, and get the total. The total you will get, you will divide the total also by 12. The year, because the total is the yearly total. And so if you're looking for the yearly average, you have to divide by 12. You get a point. Okay. Now, some people will not do it this way. Some people will do it on daily basis. They will sum up, they will record from day one all the way to the three. The year is how many days? 365. Eh? The year is how many days? 365. Eh?
65, 1 quarter.
So all the 365 days, you record all the daily figures for 365 days, put them together and divide the total by 365. It will give you the same result. So after you have done the averages, you did the monthly average, you did the weekly average, you did the monthly average, and now you are doing the yearly average by summing up all the monthly averages, dividing the total by 12, the number of months in a year. So when you get that one, you put it somewhere. Now they are two hoboko. What you close the docket. Then you come and begin another year. You go through the same procedure, you put it down all the way up to 30, 35 years. When you have gotten averages for the 35 years, you put all those yearly averages 35 together and divide by 35. And that becomes your climate. And that becomes your what? Your climate. So when you hear that climate is the average weather condition, that is how you derive climate from weather. What we have done is the climate for rainfall. We have derived climate, rainfall climate from weather or rainfall weather. So if I should say that, I hope you understand that. So that is how come we have average weather condition in the definition of climate. And that is how the calculation goes. Okay. Yeah, we have. Now let's go on. This is not in the book, but once we are discussing weather and climate, I thought that let me explain this because over interview, I'll ask you this question. We have more time. Let's start looking at weather and climate of West Africa. Yeah, no, one answer who didn't understand. Everybody was okay. And we are down to 10. Mark at 10. All right. If everybody was okay, fantastic. Now let's start the chapter itself. We are saying that we have these two things. Now, West Africa is home to air masses. That is the first point I want you to note. That air masses and the movement of the intertropical boundary in West Africa play a very important role in the determination of weather and climate of West Africa. Therefore, in telling the weather of a place or the climate of a place, you need to be mindful of what air masses there are or how the intertropical convergence boundary operates. I hope we all know what the ITCZ is, intertropical convergence zone or the intertropical convergence boundary. If you don't know what it is, tell me so that I will explain it. Correct. Okay. Now let's continue. So these two determine the weather. Now, an air mass. Let's start by defining an air mass. An air mass is a body of air in which temperature and humidity are fairly uniform. A body of air. An air mass is a body of air in which temperature and humidity are fairly uniform. And so when we talk about air mass, air is all around us, don't forget. But we can have air mass, a parcel of air. So if you push your cheeks, your cheeks, if you push them and open it, you find that air comes out. That air can be described as air mass. The air in a car tire, all right, has a certain temperature, has a certain humidity. It can be described as air mass. All right, the air in balloon, the same thing. That is air mass. And that is why, because you have air mass, that is why sometimes when you are walking around, suddenly you feel a different type of air blowing around you. Sometimes the temperature. If where you are, the temperature is quite warm, you may feel some cold temperature blowing around you. That is a certain air mass coming from a certain place because air doesn't stay at one place, it moves. And when it is moving, it either moves with the temperature, the humidity is started with, or it gets changed, which I'll be talking about very soon. All right. Sometimes you'll be walking around and suddenly a certain parcel of air will pass over your nose with a certain scent. It tells you a different air is passing around. So that is air mass. Now, we describe air mass in terms of its characteristics or its features. An air mass can be thick or thin. Air mass can be thick or thin. When do you say air mass is thick? When do you say air mass is thin? If you are on the surface of the earth, the air you breathe in is very, very thick. That is why you breathe at the pace, at the rate at which you breathe. So that if you breathe once, whatever enters your body is enough to keep you for seconds before you breathe another one because the air is thick. This is different from air on top of high mountains, air on top of or at higher altitudes. When you move higher into the sky, the air there is very thin. And so to survive, you need to breathe faster, faster, faster. And that explains why when we meet for athletics competitions, long distance, our brothers from Kenya and Ethiopia are always winning because those two countries are hilly, mountainous. And so they are up there. The air there is quite thin. So they breathe faster. And once you breathe faster, you're able to move faster. All right. So when they get to a place where the air is heavy, not too mountainous, not too hilly, then they are on cloud nine. They are in heaven. They can run without getting tired. You understand? And that explains also why when aircrafts are up there, no passenger is allowed to open the windows. Don't forget, aircrafts also have windows. But you dare not open the window. All right? Because once you close the window and the aircraft takes off, inside the aircraft, you have a certain air, which is good for those of you inside. And you took that air from the surface of the earth before you employed. Now, when you get to the high altitude, top there, so power, and you're moving, if you open the air up there, which is so very thin, is the one that will enter the aircraft, and that one is very thin. And so, if you are not careful, all of you cannot survive because you need that air to survive. That is why people are not allowed to open the windows. Unlike vehicles, when you are traveling on commercial cars, unless it is raining, eh? You open the windows and because it is okay for you. Up there, airplane, no way, you can't do that. So air can be thick, air can be thin, air can be hot, air can be cold. This one you know it already. Air can be humid, air can be dry. Again, this one you know it already. Okay. Yes, when air is humid, it means it contains so much water vapor, so much water. If it is dry, like what you experience in December, January, that one is dry. When air is humid, that is when you wake up. And so the leaves will have drops of water. It tells you that in the night, the air was so humid. Then we can also describe air as stable or unstable. When you say air is stable, it means it is not moving. And don't forget, air sometimes does not move. Air that does not move is air that is cooled. Cooled air does not move. If I don't know where you are, but I am in Kumasi. In June, in July, all right, weather was so chilling, very, very cold. It didn't rain. Maybe you didn't realize that. It didn't rain because it is only when the air rises that we get rainfall. But when the air was so cold, it was heavy. It was not moving. All right. So it will not bring any rainfall. So that is stable air. But the unstable air is air that is warm. Air that is warm. When air becomes warm, it moves. That is why if you have watched, those of us who are farmers, if you want to go and burn your farm, if you do that in the morning, you are wasting your energy. If you do that in the evening, you are wasting your energy. If you do it in the afternoon, that is when the wind is stronger because then the air has gotten warm. The sun has shone, all right? And so the air has gotten warm. Therefore, that air can move. When that air moves, it will be blowing and it will be fanning your fire for you. You understand? It will be fanning it. Hoo, 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 hoo. Then it will be burning like that. So that is what we mean. That is what we mean by stable and unstable air. Unstable air is warm air. Stable air is cooled air. All right. Now, note also that, as I mentioned, a stable air mass does not bring rain. Stable air mass does not bring rain. Unstable air mass brings rain. Take note. Okay. So we're going to look at factors that determine the condition and property of an air mass. Now, I've been giving a lot of explanation. Note that the explanations are not part of the slide, though. Okay? The explanations are not part of the slide. And so you only see the skeleton because slides are supposed to be like that. Therefore, if you don't come listen and pay attention and get the understanding, in exam, if you are told to explain factors that determine the condition and properties of an air mass, you'll be found wanting. There are two factors so far mentioned in the book. Number one, the condition of the source region. So the condition of an air mass, properties of an air mass are determined by the condition of the source region. That is the place where it is coming from. Number two, the condition or properties of an air mass are determined by modifications, changes that the air undergoes as it moves from where it started from to the final destination. These are the two factors that determine the condition of an air mass. So, as you described, as to whether an air mass will be humid or dry, as to whether it will be warm or cold, depends upon these two factors. So let me explain the condition of the source region. The source region is the place where the air mass starts from. Maybe later I'll ask you, how does wind blow? How does wind start? Every air mass begins from somewhere and then it moves, it flows, it moves. It doesn't stay there, it goes, especially from a place of high concentration to a place of low concentration. Now, where it started from may have a certain condition. The condition that the source region has is carried along by the air mass as it moves. And so, if the source region is warm, the air mass will be warm. That is why sometimes you're walking around and then you feel some warm air blowing around. You know where it's coming from. Probably somebody is burning some bush somewhere, and the air is blowing from that point. So it is warm. All right. Then again, sometimes you could feel cold air blowing around you as you move. Probably somebody has opened the cool store big. All right. And forget not that air mass shouldn't be that huge. No, it can be something small. So a buffet, then it starts moving away. It will get to you and you feel it as cold. All right. So the point being made here is that if the source region is warm, the air that will originate from that point will also be warm, and it will move on with the warmth. If it is cold, the same thing. Number two, modification changes. Now, I have said if it is warm, if it is cold, it will carry it along. But sometimes air mass may be so warm from where it started from. So maybe it started from point A, very warm. On its journey, on its way, as it moves, nobody knows where the air will be going. No. Nobody, you can't tell where a particular air mass is going. It is moving. Huh? Okay, so as it moves, it started as a warm one, oh, but as it moves, it may go and run over a cold surface. I repeat, it may go and run over a cold surface. Okay, so when that happens, the air mass will conduct the coldness. It will get some of it. Okay, and so how warm it was at the beginning, it will not be the same after running over that cold area. The same thing applies to warm air, cold air. Maybe where the air started from was cold. It was cold, so it was moving. Then suddenly it runs over a bonfire, and then it goes away. Now, when that happens, the heat of the bonfire will be conducted or will be absorbed by the air, and so the coolness will reduce, and that is the modification. So these are the two factors that determine the condition and properties of an air mass. Moving on, we're going to look at the two air masses that we have in West Africa, two of them, and how they operate in West Africa. All right. The first one is known as the tropical continental air mass. Tropical continental air mass. In geography, anytime you hear the word continental, you are using continental in opposition to marine. Marine is ocean. Continental is the land without water covering it. I hope you understand that. So when you hear continental, it means you are talking about air mass that begins from a land which is not covered by water, ocean or sea, lake, lagoon, and so on. You understand? And remember also that in the tropics, temperatures are always very warm. So if an air mass is described as tropical, to start with, it is warm. And if it is starting also from the continent, then you can imagine what it is. So let's describe the air mass known as tropical continental. Number one, it originates from the Sahara Arabian desert. It's tropical, a continental there. What dry in Subia Meho. That is the first one. It originates from the Sahara desert. It originates from the Arabian desert. Don't forget, the Sahara desert is the largest desert in the world. Number two, this continental air mass travels southwest. It comes down. It flows from the north. Huh? From the north. You know where the Sahara desert is, as far as Ghana is concerned. My connection with you has been interrupted, but no problem. So I was describing the air mass. I was talking about where the Sahara Desert is and the fact that it's the largest desert in the world. As far as Ghana is concerned, it is up north. So this air mass flows from the northern part of West Africa mm, to the southwestern part or to the southern part of West Africa. It enters the sub-region. It enters West Africa through Mauritania, Mali, and Niger. Don't forget, these are the three Sahelian countries. Three countries that share common borders with the Sahara Desert. Okay. Now the next thing, now we are describing the Sahara Desert after knowing where it starts from and how it enters West Africa. It is warm. It is dusty. It brings very little rain. It brings drought. It brings hazy condition. Warm, dusty, little rain. It brings drought and it brings hazy conditions. Hazy means, you see, in December, Christmas time, you see that um, the atmosphere will look like there's smoke, some whitish gray substance in the atmosphere. That is the haze. And don't forget that it is at this time that we have cracking leaves, cracking hills, eh, and all manner of things. Then it reaches its maximum when it enters West Africa. It gets to become so strong and powerful between in January. It gets to be powerful in what? In January. And places that are between 50 and 70 degrees north are the places that suffer. That suffer uh, from the influence of the tropical continental air mass. Okay. Now this air mass is associated with the northeasterly winds, a certain wind known as easterly winds. Okay, there's a third air mass known as easterly. That one it doesn't, have any influence on its own, but it works in conjunction with the first two air masses that we mentioned. So it has the northeasterly wind as its associate. Okay. So this one, it says that the impact of the tropical continental air mass reduces from north to south. How do you understand this? It reduces from north to south. What it means is that because it is coming from the north, places that are closer to the Sahara are affected more. They are affected more than places that are far away. And so by the time it gets to the south, its strength would have gone down. That is what it means. So that is the end of the tropical continental air mass. We are looking at the second air mass known as tropical maritime air mass. Tropical maritime air mass. I told you that if you hear marine, they are using it also as the opposite of continental. So, and this is what we call the southwest monsoon winds commonly. It originates from the marines or the ocean. Okay, that's where it starts from. And so it travels from the southern part of West Africa, okay, and enters the sub-region along the coastal areas. So a place like Ghana is a coastal area, and all the coastal countries that I mentioned. That is how the tropical maritime air mass enters West Africa. Okay. It is warm, but it is moist or humid, meaning it being warm, it still has humidity, high one, inside. And so that should tell you that it is able to move because I've told you that warm air will move. You understand? It will move. And when it moves, it brings a lot of what? Rainfall, rains. So between May and July, that is when this air mass is very strong. Strong, very, very strong. And I mean strong. But in in August, it goes back a bit and comes back stronger in September, in October, and part of November. All right. That is why at this time of the year, November, we are experiencing so much rainfall, so much of it. It started late though. It started, I think, latter part of September. But God has been so graceful to us. It has been raining since that time. Very, very much so. And that is the work of the tropical maritime air mass. All right. We are not done. It says that it is associated with the southwesterly. The first one was northeast trade wind, so it was associated with the northeasterly. This one is southwest, so it is associated with the southwesterly. Southwesterly. Southwesterly wind. As I said, this wind doesn't have any effect on its own. It works with the other winds to produce any kind of effect. Okay. And the last thing about that air mass is that the impact, the impact of that air mass reduces from south to north, meaning that as you move from the southern part heading towards the north, rainfall will reduce. And that is why in Ghana it rains more at the southern part than at the north because the south is closer to the ocean and therefore it experiences the full effect of the continental air mass. That is not continental, the maritime air mass. So these are the two air masses that we are talking about. Well, in case I am unable to take you up to 3:30, then you will say that our meeting has been well made. But yeah, we are soldiering on. From there, let's look at the next one. Um, yes, we are talking about the easterly air mass. Easterly air mass. It is originating from the Indian Ocean. All right, that is where it is coming from. It's a tropical air mass. That is where it is coming from. Indian Ocean, meaning it is also humid. Okay. Now this air mass, it doesn't have so much water vapor as compared to the maritime air mass. It doesn't. And then the only work it does is that it is the one responsible for all the storms. You know, when it rains, you have storms. We have windstorm, rainstorm, thunderstorm. You know them. So anytime you hear there is a storm, that is the work of the easterly air mass. Left to the monsoon winds alone, the maritime air mass alone, it will produce normal rain. It will produce normal winds. It will produce normal situation. But as soon as the easterly air mass comes to mix with it, all right, it gives extra strength to the air masses so that they produce some of the things we are talking about in high volumes. If it is rainfall, it rains heavily. If it is wind, it blows heavily. So that is the work of the easterly air mass. That is the work of the easterly air mass. Correct. Now let's look at how um, relief influences weather and climate. How relief influences weather and climate. How relief influences weather and climate. Are you ready? Good. Mm. You know that the elements of weather and climate are blah 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 as you mentioned them. So what is temperature? How does temperature influence weather? Highland areas like Fitajalon, blah 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 blah, and highland areas like the Sierra Leone highlands, Liberian highlands, and so on, have low temperatures due to elevation, due to high elevation. Now note that as we say in geography, that the higher you go, the cooler it becomes. So if you're on a higher mountain, you are likely to have um, lower temperatures, low temperatures. Okay, as to why that happens, I can explain, but this is not the forum. If you want me to explain, maybe the next lesson or some other lesson. But remember that areas that are having highlands, usually those areas are very, very, very cold. I hope you know that. And that explains why places in the eastern part of Ghana, for example, talking about Abetifin, mm, Koum, Praiso, all the mountainous areas in Ghana. That is why they are very, I've been to Abetifin before. Very, very, very cold. Very, very cold. Because the heat that we experience on the surface doesn't get to that point. So those places are very cold. Again, highland areas also have high rainfall. Highland areas also experience high amount of rainfall. Question is how and why? Three types of rainfall. All of them are happening there. Cyclonic, uh, cyclonic, convectional, and relief. All of them are happening there. As compared to the other parts where only two types of rainfall are happening. So that is how any of the elements or some of the elements influence relief. Okay. Now, it says that the highland area, there are some highland areas that are in the rain shadow. Okay. They are in the rain shadow. Remember that if a place is high, it is likely to experience high amount of rainfall because highlands will force air masses to rise, and when they do, they rain. So where the air masses rise, that is where the rains will fall. Therefore, if you're on the other side where the air masses are not rising, you will definitely be in the rainfall shadow. So these highlands, as you mentioned, create create rain shadow effect as rain-bearing westerly winds lose moisture over the Guinea Highlands, Cape 3 Points, the Mampons Cap, Akwapim Togo ranges, and so become dry westerly. They become dry westerly. All right. Simply, places that are in the leeward side, and you remember that word, leeward side, will not experience heavy rainfall. Places that are in the windward side will experience heavy rainfall. Okay. Now, let's talk about latitude. I've already told you that um, how far you are, if you are high up in the sky, your temperature is likely to fall. All right. So places that are closer to the equator experience constant high temperatures because at the equator, the amount of energy received is very, very huge. And so if you are closer to the equator, you are likely to have high temperatures. All right. You are likely to have high temperatures as compared to those who are far away from the equator. Okay. And then only a few places in West Africa experience temperatures. Oh, experience temperatures or cold temperatures below 20 degrees. What it means is that the greater part of West Africa are always warm. Temperatures are always high in some of those areas. Uh, Only a few places in West Africa, you can name them, experience temperatures below 20 degrees Celsius. And that is to say that if you are on a higher mountain, your temperatures are going to be very low. Okay. Now, how do these elements also influence? No, how do um, these elements influence rainfall? That's the point. How do these elements influence rainfall? It says that the coastal areas, starting from starting from Sierra Leone to southeastern Nigeria, experience heavy rainfall. So, including Ghana, exception to the above is a small area. So that means that all the countries along the coastal stretch of West Africa experience high amount of what? Rainfall. So from the Gulf of Guinea inland, rainfall decreases in amount. As you journey from the coastal area, okay, so let's use Ghana as an example. Start from the coastal area. 3 days ago, I was in Cape Coast. So let's start from Cape Coast. That's where I know, or even from Accra. We are journeying towards um Ashim areas. Okay. Um, Nkoko, Nkoko, Accra, Ekoni Ashim. Okay. Then we are coming now all the way to Konongo. Then you pass through all the way to Kumasi. Then you turn to the north. As you move away from the south to the north, okay, especially if you leave the forest zone, rainfall will be what? Reducing. All because you are moving away from the Gulf of Guinea, the coastal stretch, and you are now entering the savanna zones. It is so everywhere in West Africa. Okay, so we have said that those along the coast or places closer to the ocean will have heavy rainfall. But we also know that in Ghana, especially, all the areas along the coast, starting from Adan all the way to Azim, they experience low amount of rainfall compared to the forest zone, for example. So the book wants us to look at why that is the situation. But there are some four reasons why areas, even though they are closer to the ocean, still do not experience high amount of rainfall. That is the coastal stretch, and I've told you where it is. Okay, so the first reason is that the southwest monsoon winds, the tropical maritime air mass, if you remember, yes, they rise from that place. Remember, but they blow parallel to the coast. Okay, they blow parallel to the coast instead of blowing vertical to the coast. They blow parallel. So it is like they don't meet. They run along the coast, and that means that they are not going to rise. So the winds that rise from the ocean uh, do not rise along the coast. They rather travel inland and get risen. They rise inland. And when they rise, that is where they bring rainfall. So if they don't rise along the coastal stretch, it means they are unable to bring any rainfall. They do, but not in larger volumes and quantities as you experience in the forest zone. So note that the tropical monsoon maritime air mass blows parallel to the coastline. That is why the coastal area in Ghana and Togo, the coastal areas in Ghana and Togo are dry or the driest part. In fact, in Ghana, the driest part is not enough. The driest part is along the coastal stretch. You understand? The driest part is along the coastal stretch. Okay. So that is the first region. They blow parallel to the coast. That is why. All right, let's look at the second factor. The second factor has to do with the fact that there is a body of cold water off the shore from Cape Three Points eastwards. There's a body of there's a body of cold water off the shore from Cape Three Points eastwards. When the maritime air mass passes over it, it chills or it cools. And you know, when it cools, it's unable to rise. You understand? It can't move. If it is unable to move, it is not going to bring any rainfall. In fact, after this heading, I may close. It's running up to, hey, I was saying, yeah, it's running up to 2 o'clock. It's supposed to have closed when 3:30, eh? Yes, because of some reason I may close. So, Vanessa, what I'll do is that I'll beg for one evening. Huh? I'll beg for one evening and meet you. So you will decide which of the evenings. Please do that so that we can complete our listen, our subject area. I have to go and attend to an equally important exercise. So I may close after this heading. Okay. So the third one says that the southeast plains are generally flat or undulating with few in suburbs or plains. So over there along the coast, the place is quite flat. And don't forget that winds are forced to rise by the highlands. And so if there are no highlands, I wonder how they are going to rise. So they rise rather over places where there are highlands. And so it leaves the coastal stretch bare without rainfall. And the last one is that the rain giving storms coming from the east deposit their rain on the Akwapim Togo ranges, that is the southeast coastal plains, now will fall in the shadow area of the Akwapim Togo ranges. Simply, we are talking about a situation where um, we have the leeward side and then the windward side. Winds will rise on the windward side. When that happens, places that are in the leeward side will not have rainfall. And so the eastern side of the Akwapim Togo ranges is always the plains, the coastal plains. Therefore, winds that are coming are forced to rise by the Akwapim Togo ranges. So they don't get to the eastern side to drop any rainfall. All the rains are dropped on the mountains, Abetifi and Praiso, the Kwao areas. It puts Accra and the coastal stretch in the shadow. And that means that it will not have any substantial rainfall. All right. I may not be able to continue after this point. I have about 1.5 hours to finish, to end. So I will end here and then beg for one day. I'll be in touch with Vanessa. Vanessa, be in touch with me so that we decide on which of the evenings from 7. Then we meet and then see what we can do. All right. Thank you very much for the attention and sorry for not being able to run fully with you. Okay. Bye bye.